All right, everybody, and welcome once again to the Daily Space Weather. Today we see another coronal mass ejection unfolding. How right were we? Or were we wrong about the coronal mass ejection forecasted to arrive today? And cosmology stories galore. First thing we'll do is take a look at the sun here. We see two sunspot groups. One in the south, one in the north, pretty much at the same longitude there. And the northern one, which is sunspot 2804, has actually grown a bit. We see a bit of a consolidation of the trailing umbrae and a bit of growth in the leading umbrae. And the southern sunspot group, 2805, is actually spreading apart here a bit, increasing the probability of some solar flares, some X-ray flares. So we've got some more views for you here. First, I just wanted to make note of the fact that at Lagrange point 5, we're seeing old data once again from stereo A. There may have already been an additional coronal mass ejection. So we're at Lagrangian point 5 here from stereo A, and there will be another coronal mass ejection here, and we'll have to keep you posted later on what the status of that is. As we've got old data here, we're not seeing any data from today, the 24th yet, so we'll just have to wait for that and possibly look at other instruments. So here are some more views. Here's 304 angstroms. That filament in the southwest corner, as well as sunspot 2805. Spectacular filament down there in the southwest. So here's the magnetogram. This will give you a little bit more detail as to what the activity of those sunspots are. You can see down here, this one's spreading apart, 2805. And again, that does increase the propensity for solar flares a little bit. And the northern sunspot group, again, has grown a little bit marginally in the past 24 hours. Here's one more full disk view. It's 171 angstroms, my personal favorite wavelength. And we've got to blast through a whole bunch more data, including some fascinating cosmology stories, here at the smAsho News Network. All right, so next we're going to show you a diagram of the solar system. And if you watched our daily space weather supplemental video yesterday, you would have seen Venus showing up on the LASCO C3, the closest planet to Earth and the third brightest object in the sky. Anyway, there's where things are in the solar system. And there's where they'll be in a week. Here's a star chart. I'm going to leave that on the screen for a very brief period of time. I've drawn in the yellow ecliptic line there, and I've faced mine to the south, as I'm currently facing to the south. My sofa also faces the south. The radial flux has come up to 78, and that's another forecast that we hit here, forecasting that we would see a rather sudden uptick in solar activity. And indeed we have. So there that is in context. It's the 1-year chart of the radial flux, which is this upper black line here. And that's a welcome sight. We haven't seen any of the geomagnetic storm forecasts arrive. And it turns out the coronal mass ejection did indeed strike. It's what we would call a glancing blow. And it's really overshadowed by the coronal hole wind stream. We have not yet, at least, seen a geomagnetic storm. You can see the forecast there for a geomagnetic storm. Never really saw that, although we did get into a period of geomagnetic unrest, a slight intensification of the solar wind. We'll show you momentarily. First, volcanoes. Are you wondering what's erupting? Well, Etna looks like it's still continuing to erupt here as it after it's abandoned its 35-hour periodicity. Still erupting, though, and that's an image there from Etna's new southeast crater. A little bit of new real estate being created on the island of Sicily. Sakurajima also erupting, flight level 080. It's an 8,000-foot ash plume there. Suwanosejima exploding, flight level 070, 7,000-foot ash plume. Raung, I believe that's an uptick at Raung on East Java. Flight level 140, 14,000-foot ash plume. Mount Ibu on the island of Halmahera in Indonesia, exploding. 6,000-foot ash plume. Semeru on East Java, exploding. 14,000-foot ash plume. Popocatépetl, exploding. 19,000-foot ash plume. Fuego now back on the list, exploding. 15,000-foot ash plume. Sangay, Revenador, and Sabancaya all exploding. 22,000-foot ash plume, 15,000-foot ash plume, and 24,000-foot ash plume, respectively. Sangay is located in Ecuador, Revenador in Ecuador, and Sabancaya in Peru. Let's see what earthquakes have been kicking up over the past 24 hours. And we actually saw, I think the largest of the past 24 actually occurred on Iceland. We'll save that for the end of the earthquake coverage. A couple deep quakes yesterday, such as this 184-kilometer depth, 4.5 magnitude Philippine quake. And then about 2 hours later, a deep quake at Vanuatu. Those both at a 4.5 magnitude. The Vanuatu quake just under 100 kilometers depth. Deep quake at Chile, 111 kilometers depth. Another deep quake in western South America there. That one in Argentina, 187 kilometers depth. Another deep quake in Vanuatu. Another deep quake in Vanuatu. Those only 6 minutes apart, but at distinctly different depths. So we see a 5.0 at 129 kilometers, and then 7 minutes later, a 4.6 at 208 kilometers depth. So it's a deep quake event officially, folks. A 4.3 at Bolivia. And the depth of that is 275 kilometers. An ultra-shallow quake at Tom's Place, California. Let's check the location of that, as it's at an altitude of 600 meters above sea level. That one located northeast of Long Valley, near the Nevada border. In the hills between the Adobe and Benton valleys. It's only a 2.5 magnitude, and again, this 5.6 occurred at 5 after 5 Universal Time this morning, quite near to Reykjavik. So if you felt that quake, leave us a comment. The epicenter just on the shore there, near the town of Grímslavkurbeir. Grímslavkurbeir. By the way, this Smash stream is brought to you at twitch.tv/smashamash. Thanks to our followers over there. It's a great streaming platform. Don't forget to visit our own website. As we are alt tech, we saw the writing on the wall years ago. You can find our social media. You can find our links to our merch shops. Today I'm wearing the Google Bias shirt, as you can see here. To use it in a sentence, I Googled it. Now I know less about it. If you're viewing on YouTube, please press like and subscribe. And if you're viewing on BitChute, please view on YouTube as well. Also, same to you Twitch followers. There's lots of exclusive content over at youtube.com/smashamash, so make sure you subscribe over there. Tell your friends, tell your foes, tell your science noobs, and your science pros. And if you didn't see yesterday's Daily Space Weather Supplemental, we reported on additional coronal mass ejections occurring. We will leave that on the end screen today, so you can view that if you didn't. Some spectacular imagery of coronal mass ejections. And thanks to our subscribers over on BitChute. If you're only viewing on YouTube, view on BitChute as well. There's exclusive content there. And let's go into a cosmology segment. It's quite full of information today. We won't be doing anything random, as is there anything really random in the universe anyway, folks? First of all, how about an unprecedented map of the sun's magnetic field, including the mysterious chromosphere? Yes, this SciTech Daily article talking about the clasp 2. Normally we'd only be able to see the chromosphere during the times of a solar eclipse, but fortunately that has changed. And I'm just letting the SciTechDaily.com article here scroll. The clasp 2 is a small suborbital rocket, and it's helping to reveal the magnetic fields. So the chromosphere is the area in between the corona and the photosphere. It's the part that we're looking at when we look at those different wavelength views, like 304, 171 angstroms. And the clasp 2 revealing some of the magnetic structure of that. And since the sun is the Rosetta Stone of all cosmology, this is super important, and it's part of the reason why we cover heliophysics on the daily. And I'm not going to get into what's going on with that, the Zeeman effect. I'm not even going to go there. I'll just put up this diagram to show you the solar layers. And move on. Again, that article's on SciTechDaily.com. And now I don't know what we're looking at. We're not going to be talking about the inner ear today. All right, let's continue on here. To talk about Cygnus X1. So Cygnus X1 is the first object widely believed to be a, quote, black hole, end quote. I prefer not to use that term. I prefer to use massive radio source. Here it is on the Swift Bat Flux. It is a very bright X-ray source located in the Milky Way galaxy, once believed to be at about 6,000 light-years distance. There's an article here, of all places, on extremetech.com. And according to a newer survey, this object is about 1,000 light-years farther away than expected, therefore significantly larger than originally believed. This is the same, quote, black hole, end quote, that Stephen Hawking and Carl Sagan famously betted on. Once believed to be about 15 times the mass of the sun, now believed to be about 21 times the mass of the sun, as this massive object orbits a supergiant star. So that's just an artist's rendition right there, folks. If you want to read about X1, that one coming out a couple of days ago there on extremetech.com. Speaking of massive radio sources, to which some refer as black holes, how about a sky survey of ultra-low, well, not ultra-low, but low-frequency radio waves featuring 25,000 black holes, a large portion of the sky mapped in 250 megahertz and lower radio frequency. So this one's on Universe Today, and the low-frequency array is a series of lots of telescopes across Europe, and they're measuring, again, below 250 megahertz, which are the lowest radio frequencies able to be seen from Earth. And so another fascinating image here. It's got 20,000 antennas located at 52 stations across Europe, and it takes a lot of computing power to tie together all of that radio frequency data. A very detailed image of 25,000 black holes across the night sky. And there is that image once again. Fantastic cosmology story. And continuing on, we've got one more. Mysteries of the Milky Way are revealed in spectacular detail. And we ain't kidding. Talk about a high-resolution image. This one is 50,000 by 25,000 pixels, and there is a link on this article to the zoomable version. So if you'd like to zoom in on the bulge, the central bulge of the Milky Way galaxy, head to scitechdaily.com. And here's the part of the sky that it is. Now wait a minute. There it is. There you can see the central bulge of the Milky Way galaxy. It's just this tiny little section, but it's very high resolution. Here's a tidbit. That wasn't a tidbit. Haha. So I zoomed in on one of the void areas. So you can see that void right there. It's got some massive hot blue stars in there. And check it out, folks. It must be an alien spacecraft. A series of alien spacecraft here. Oh my God. Who would have known? Who would have guessed a bunch of alien spacecraft showing up there around the extremely highly populated core of the Milky Way galaxy? Just kidding, folks. Those are some kind of artifacts. But that's a great spot to zoom in on. Some fantastic detail. And you can zoom way, way in to this massive high-resolution image. And again, you can link to that at scitechdaily.com. Some great articles there today. Nice combination of stars in this area. Some blues, some reds, some oranges, some whites, and some yellows. So that's today's fascinating cosmology segment. Let's get back to the regular space weather. Looking at solar flares, we don't see any major ones, although a B-class flare is kicking off as we make the video, it looks like. Interesting, interesting. Let me hit refresh here just to make sure that we've got the most current data. Little B-class flare happening as we make the video, and thanks to the sun directly. Dear the sun, if you're listening, cheers. Thanks for supporting the channel by engaging in activity. Mysteriously, while we make videos time and time again, all kinds of live streams, including the largest solar flare of the past several years, the M-class flare that happened while we were streaming live. Cheers, and thanks to the sun for supporting our channel. We don't see any major proton strikes here, and this is the main forecast of a coronal mass ejection. You can see no strikes, despite that little glancing blow. No protons showing up at the GOES-16, which is measuring at the ionosphere layer. Here's a real-time solar wind to show you this weak glancing blow of a coronal mass ejection. It's barely even anything to talk about, but you can see this signal right here, this uptick in the temperature and the speed and the density all at the same time, coupled with changes in the BT/BZ and changes in the phi angle. That is a coronal mass ejection. It's barely a strike, and looks like it may already be subsiding here. The speed having only reached 515 kilometers per second, where the coronal hole wind stream got us over 600 kilometers per second. It's a very weak glancing blow, barely noteworthy. The current solar wind density 8.48 protons per cubic centimeter. Current solar wind speed now under 500 kilometers per second at 489 kilometers a second. And you can see these pulses here. It's barely even making it. You can see this solar wind temperature here dropping back down to baseline levels. It looks like it's subsiding promptly. It was enough to get us back into geomagnetic storm conditions. I would expect this to subside back to a KP3. Current conditions over the past 3 hours are KP4, geomagnetic unrest. Today we're going to show you the velocity and the density and the pressure when it comes to the magnetosphere. And just let me check the life of the stream, and it looks good to me. So here is the velocity, and you can see lots of high velocity there in the magnetotail region especially. although also near the day-night terminator here on the left pane. That is the plasma surrounding the Earth in the magnetosphere getting re-accelerated back into the solar wind. I'll let it play through a second time. It's not because of Nibiru. Next, we'll show you the density. Keep in mind this shows high density in dark blue and low density in white. It only includes a range of 0 to 4 protons per cubic centimeter. Not particularly high resolution. We'll let it play through. It's 4 hours of data, courtesy University of Michigan. And you can see density spikes in the same regions where that high-speed reintegration into the external solar wind occurred on the previous slide. And here's pressure. And we see quite a bit of pressure here. Again, geomagnetic unrest conditions. We'll show you auroras right after we show you the ground magnetic perturbation. So here's the Earth's B field. It's induced magnetism from the incoming solar wind. I'm showing you the polar view here. And we're looking at changes in the Earth's magnetism, the Earth's B field, the field that goes through the magnet. So delta B, that means change in. In science, whenever you see delta, it means change in. And it's measured in nanoteslas. Some significant magnetic perturbations there over the Siberian North Pole especially, less so the Canadian ones so far. Here's the global view, which is actually showing significant perturbations over the Canadian North Pole. Yeah, we've got two, and the South Pole is somewhere south of Australia. So here's the auroral forecast. And once again, we expect to see some photographs of aurorae. We don't usually show it on the channel. That's basically just aesthetics. And we should see this kick up in the last little bit of the video here. And it looks like northern Alaska got a pretty good light show there. Next, magnetic data. Here's the GOES magnetometer on the GOES 16, and it's you see these spiky readings here. You see quite high readings at midnight, or close to midnight. Once again, that was forecasted yesterday. We see pretty high levels of magnetism here. Next, looking at the current sheet. Here's the heliospheric current sheet. It is the solar wind via polarity. So the red portion there, that's the current sheet that is oriented to the south solar polar field. The green current sheet there associated with the north solar polar field. Earth still solidly in the south pole current sheet. And again, there are additional coronal mass ejections happening right now. Keep in mind this data is 2 hours and 3 minutes old from when we made the video. And we'll still be in the South Pole current sheet when we make tomorrow's daily space weather. Here's a line of sight field plot. It shows you the poloidal fields and the solar magnetogram as well. It also shows you the sun's B field in blue. No major changes there in the B field, despite two sunspot groups. And here's the coronal hole plot. There is another nearly equatorial South Pole oriented coronal hole moving into the Earth facing zone. So we're seeing no shortage of activity here. Lots of stuff happening. And last but not least, here's the magnetic field plot of the solar corona, the sun's atmosphere, a chaotic place. It shows you potential field surface source lines, open ones in black or purple, depending on if they're at the poles. and closed potential field surface source lines in pink. Here's a diagram of the atmosphere. If you need to pause it, feel free. We'll be here when you get back. Here's a diagram of the Van Allen belts, the radiation belts surrounding the planet. Let's talk electrons. We see some charging hazards here over places like Mexico, the Caribbean, and the North Central Pacific, as well as over the South Atlantic, South Indian Ocean, and Southwest Pacific. Electron flux made it to very high levels here. We saw levels at just about 20,000 pulse flux units, I believe it was. And we are currently in electron flux warnings. Don't be surprised to see some satellites shutting down briefly as a result of this. Things like CCD bakeouts, charge-coupled devices shutting down to prevent themselves from being damaged as a result of so much relativistic electron flux. So here's the one-year chart to put it in context. And here is the total electron content visualization. And we see pretty organized electron belts here in the total electron content forecast. It'll show you GPS errors. And here's the forecast for the next 3 days. It's for slightly higher levels. And I would tend to agree. I would tend to agree with the forecast, which is the green boxes, the yellow diamonds would be the observation. Here's the ionosphere. This is approximately where the GOES-16 endeavors to make its measurements. Looking pretty normal there in the ionosphere. Latest image coming in at 10:45 Universal Time. Next, looking at meteorology subjects. Here is the nullschool.net 250 hectopascal winds. This is the jet stream scenario. We see some very kinked jet streams here in the southern Indian Ocean, south of Australia, near where the southern geomagnetic pole is located, actually. And it looks like some extreme Arctic air being pulled down into the Middle East. Here are the jet streams of the Western world. And we see extremely disorganized jet streams, especially in the southern hemisphere. Also doubled up jet streams in the northern hemisphere. It looks like it's going to be a hot day in Central America as equatorial air is pushed up. Here's the South Geographic Pole real quick. And if you follow me on Twitter, you may have seen some imagery of that a little earlier. Next, looking at a real-time lightning map. It's lightningmaps.org. It's where I go when I hear thunder. It's the best way to convince your friends that you're Thor and your foes that you're Odin. Tell your friends and foes that you're causing thunder to occur, not just forecasting it, at lightningmaps.org. A little more lightning here, as we saw about a 4-day lull globally in lightning. Next, looking at pressure maps here on windy.com, who's got a great mobile app as well, by the way. And check out this low-pressure trough here. We've got this low-pressure trough going all the way from northeastern Australia all the way down to the South Pole. A continuous line of low pressure there. And here's where the GFS forecast has pressure cells at 12 noon tomorrow, and that's Eastern time. We're located in Lehigh Valley, Pennsylvania. Here's what's going on in the cloud layer. Despite it being dark, we show it daily anyway. And it's pretty fair skies over most of the U.S. right now. Not a lot of precipitation at all. Here's the water vapor map to help put that into context. And we've got an overlapping system right here. Let's actually zoom in on that. Going to zoom in on this area near the Texas-Oklahoma border there. It's not gravitational waves, folks. That's an upper level system on top of a lower level system. And there's a massive pressure gradient here between this moist air and this dry massive air down here. Here's the full image once again. And there's the cloud layer. Low clouds finally subsiding a bit over the Atlantic Ocean. Some still over the Gulf of Mexico, though, as well. Here's a U.S. Doppler radar map, and you can see pretty clear skies over most of the U.S. Some snow showers in the northwest, and some heavier snow there over the north central portion around the Great Lakes. A little bit in Maine, a little bit in New Hampshire. And hey, Smash Team, thanks for tuning in. Once again, don't forget to press like and subscribe if you're viewing on YouTube. Please share with your friends and foes. Share on your social media. Who knew we'd be the world's leading solar forecaster? Here we are. It's just the way the cookie crumbles. And we've got bonus features. So don't go nowhere, see? Because we got to show you the high-res image here. The high-res image here of the sun. See what I'm saying there? See what I'm saying? Here's the intensity gram there. Boy, that's an awful nice sun you got there. It'd be a shame if we zoomed in ultra high res. There's sunspot 2805, which looks like it's degrading a little bit. Although, again, these umbrae have started to spread apart. It is still beta class. There is still potential for possibly some C class flares. And this one has grown here. So you can see actually seeing some penumbral lines there. That's a beta class as well. And the possibility for solar flares a little bit higher out of this one. There's a great view of the magnetic regions. And there's sunspot 2805 as well. Finally, we've got some additional imagery here. Here's the 193 angstroms view. And we'll show you a close-up of that coronal hole there in the southern hemisphere. First, we'll show you the northern hemisphere. And a great view there of sunspot 2804. Fantastic, simply fantastic. Here's the southern hemisphere. And a great view of sunspot 2805 and that incoming coronal hole. We'll keep you posted on when the wind stream from that is going to arrive. And last but not least, 304 angstroms. Again, don't forget to check out the video on the end screen here. We'll put up the video from yesterday's in-depth coverage of yesterday's coronal mass ejections. You'll have to view the video to figure out if they'll miss or strike Earth. Again, there's probably a coronal mass ejection unfolding right now. We've got some old data. We'll have to make another video later about that. Thanks for tuning in. Remember, stare at the sun, attempt to understand the physics. Don't drink it. If you do, don't drive. Once again, welcome to the Neo Renaissance. Visit our link, support the channel that way. And may that solar wind be at your back.
Just a good old smash. Never meaning no harm. Beats all you never saw. Been in trouble on social media since before its existence. Straightening facts. Smacking down hacks. Someday our viewers might get me, but Big Tech never will. Making my way the only way I know how. That's just a little bit more than Big Tech will allow. Just a good old smash. Wouldn't change if I could. Fighting the nonsense, it's a neo-renaissance in the